Welcome to the Cost of Everything podcast. In this episode, I talk with Ricardo Valerdi, Professor in Systems and Industrial Engineering at the University of Arizona, all about his research in cost estimating, how he applied estimating principles to sports analytics, and how storytelling with data is becoming an increasingly important skill. Thank you for joining me today, Ricardo. You're quite an esteemed person within the cost estimating community. You were mentioned quite a few times to me when I was doing my own doctorate by my supervisor. So thank you for joining me.
Thanks, Amrit, for having me.
I think really just to get started so that the listeners maybe who aren't in estimating can find out a bit more about you. Just what is your background and how did you get into cost estimating, research in cost?
I'm an electrical engineer by training, but I have also degrees in industrial and systems engineering. And currently I'm a professor in the Department of Systems and Industrial Engineering at the University of Arizona, which is located in Tucson, Arizona. So if you're familiar with some of the Beatles lyrics, they mentioned Tucson, Arizona in one of their songs. So I don't know if they made a trip down here or saw it on the map and wanted to come, but you may have heard about this town before. In terms of my connection to cost estimation, I came across the topic initially as a master's student at the University of Southern California, and I was paired up with Barry Baim, who is a very well-known professor in the area of software engineering and also the developer of Kokomo, which is one of the early software cost models. And Professor Baim eventually became my thesis advisor at the master's level and then dissertation advisor at the PhD level. And studying under him, I just became more ingrained into the area of software costing initially, but then more broadly estimating the cost of other types of effort like systems engineering. And eventually wrote my dissertation on that topic and have been doing research in that area ever since.
I've talked to a few people who not initially interested much, not really in the estimating side of things, but sort of not drifted into it, but their skill set really then helped with going into estimating. What is it about systems engineering that sort of lent itself to what you were developing from cost estimating? Because you went on to develop another system, and I always get the name wrong with this because it sounds very similar. Is it Cosismo? Was it?
Cosismo. That's right. I mentioned Kokomo earlier, and that stands for the constructive cost model. And what Kokomo was focused on was specifically estimating the cost of software development effort. Now, it's not the only model that does that, but it was one of the earlier ones that helped answer the question, how many software engineers will I need to build this piece of code or this computer program? And that model has been used for over 40 years with its appropriate modifications and improvements since that time, but there's a whole community of Kokomo users and researchers. And it's within that ecosystem that I was able to create a sibling model called Cosismo, which stands for the Constructive Systems Engineering Cost Model. Some similarities in terms of the methodology, the approach for sizing the job in terms of how large it might be, and using that information to translate it into effort in terms of person months and subsequently cost, whatever currency you might be working in, whether it's pounds, euros, dollars, etc. But different in terms of focusing on a very narrow piece of a broader project, which is just the systems engineering part. So in the same way, Kokomo was focusing just on the software development part, Cosismo was focusing just on the systems engineering part of think of a large defense program that might have different disciplines like hardware or mechanical engineering or software and systems. So in a sense, each of these models chips away at part of that different slice of the pie, so to speak, to be able to roll up and come up with a macro estimate, a macro result for the entire program.
Just going to systems engineering and employing Cosismo, is there a particular stage in the development cycle that you employ this? Is this at the very early stage where you're trying to work out, so like you say, at a macro level, you haven't got the detail, but you have certain parameters that you know about, and then you use this as a number to give you a directive, and then you do something more bottom up later on, or does it employ some level of bottom up estimating as well?
The question of when to use these cost models is important because they cannot be used too early because they do require a certain level of information or a certain level of detail. And in the case of Kokomo, you would need to know at least or have an estimate at least of how many lines of code or function points or object points there would be in that project. So until you know that information, Kokomo is really not very useful. And Cosismo operates in a similar way. You'd have to know at least have an estimate of how many requirements there will be in the product, how many interfaces, how many algorithms, and these could be estimates, so they don't have to be rock solid, but there's certainly an expectation that you at least know some basic information or can estimate that basic information to be able to generate an estimate that is based on at least some facts and some data. Uh, and typically that happens after the project has gone through some systems engineering, architecting. You can call it maybe upfront design iteration. It does require some effort to get to that point, but it's almost like anything else. The better information that you put into the model, the more confidence that you can have in the answer actually being meaningful. So you don't want garbage in because you're going to get garbage out. You want solid information in so that you can get at least some confidence in the output.
That's often the case with any tool that we use. It's understanding that crap in, crap out, and there have been quite a few occasions where, as a practitioner, you get into a situation when someone says, "I just need a number," and you're saying, "What do you need a number for?" And then you start trying to work out what the basis of the estimate is, what the purpose is. The further detail you go into, the more you realize actually there's not even any requirements definition. There's very little idea of the scope of the job. And the stage that you're talking about, optioneering, is where most of the decisions can be made and where most of the cost is locked in, essentially. So having a tool that is at least reliable, providing you with outputs, and aligning it with systems engineering, which is the basis of a lot of complex product development, it's a useful system to have in place. I was just thinking, you've probably seen the model that you developed and the system that you developed used in multiple different ways. What is the most unique or strange, or I guess random application of either Kokomo or Cosismo?
I can speak to a few unexpected applications to Cosismo. Uh, One application that was unanticipated was in the automotive industry. And as you can imagine, the automotive industry operates really at an annual drumbeat or semi-annual because they're trying to get a new product out every year or a new version of a vehicle out every year. And that is a very different pace than the defense industry, where there isn't this um, urgency to put out a new model as often. And there's more focus on safety, reliability, and sometimes things like interoperability. So while the Cosismo model was built primarily with aerospace and defense projects and expertise, seeing the Cosismo model used in something outside of that domain, and I go back to this automotive example because it gave me some really good ideas about how to make the model more versatile or more generalizable. Specifically, the model has a size driver called the number of requirements. And for a defense project, that number could be massive. It could be hundreds or maybe even thousands of requirements of varying complexity. Some of them a lot harder to implement, a lot harder to test. But in the automotive industry, you don't have that many requirements, especially when you look at a subsystem of the vehicle, maybe the navigation system. So you might have in that context tens, maybe at most a few hundred requirements at most. And their level of complexity is much different than in the aerospace industry. Of course, safety and reliability and quality do matter a whole lot in automotive, but it's different when you're considering building a weapon than when you're building a car. And so just the level of adjustment that needs to occur in a model like Cosismo really helps from a research standpoint and a model developer standpoint. It really helps realize what kinds of things can be learned from the model being used in a context outside of which it was originally developed for.
I've moved across industries to something which is more product development to infrastructure, and you do notice a difference in terms of life cycles, project life cycles. Yeah, I think requirements, dependencies within those requirements as well. I think some aspects are the repetitive nature. I think probably would help in terms of training any kind of model as well, and really understanding where the inaccuracies are in your model. And I think that's something that automotive probably does provide, especially if you're an original equipment manufacturer providing something that's on a reasonably large production scale. What I was thinking was that there might have been some kind of random applications, because where you took your research and where you moved on from, it seems like a very different world. So, I mean, I know you've done research in sport as well. How did you make that connection from cost estimation to sport?
That is an interesting connection, and one that to me now is very obvious, but when I first started, maybe it wasn't so obvious. What really solidified it for me was reading the book Moneyball. And it was authored by a gentleman named Michael Lewis. And what he tried to accomplish was to explain the story of a professional baseball team here in the United States on the West Coast in Northern California, the Oakland Athletics. And what Michael Lewis described about the Oakland Athletics is that they were able to find some inefficiencies in the economics of the sport and then exploit those inefficiencies in order to win more games at a lower payroll, at least compared to other teams, other competitors. And the team that would often be used to compare the Oakland Athletics was the New York Yankees, who fell essentially on the other end of the spectrum, who were winning about as many games, but they were doing it at a much higher cost, at a much higher payroll. So you can immediately see that there's a cost connection between the work that I was doing in the defense industry and cost modeling and the sport of baseball. But even beyond that, it's really about measuring human performance. At the end of the day, baseball is a team sport, but so is engineering. And you have to have the right players in the right positions. You want to be competitive, so you try to find ways to bring the best players onto your team to win. And it might be to win contracts or to execute projects successfully because that's what generates profits is successful execution. And so there are a lot of parallels in terms of the end objective for baseball and the end objective for companies. So that got me really excited, and I just kept digging into the connection between sports in general, not just baseball. I actually broadened the thinking to include basketball and American football and Olympic sports. So that's been a bit of a hobby for me, and it's been a lot of fun because there are actually a whole lot of connections between engineering and sports, not just in a physical sense, but in an analytical sense as well.
Since the birth of social media and well, since the explosion of social media, more accurately, especially in recent times, the number of different stats, I think more in soccer, the stats have totally changed from where they were and how players are judged. For years, I've watched cricket and people talk about averages, and then strike rates became a big thing. And then in football, we're talking the number of goals scored in a season, match-winning saves, and now it's gone to number of assists, number of sprints made, number of passes, and then there's a lot more nuanced sort of analysis that happens in the background as well. And you can quite clearly see, I mean, I don't know whether it's just a coincidence that the Fenway Group took over Liverpool, and then Liverpool bought players who weren't really considered to be at the top, were relatively cheap. And okay, they bought one or two players that were breaking the bank a bit. And I was a fan of Moneyball when I saw the film, and then that's when I started hearing about it. It must be very similar principles being applied now to soccer, and you can see that with other teams emerging around Europe as well, where they weren't challengers before. So I think making that connection, I think you're right that cost estimating is very analytical, and you're trying to not just measure human performance, but predict the capabilities, and understand what the likely performance is going to be in the future. So it's a very linked skill set. Where do you see that going? Do you see specific? We've got big data and we've got machine learning and everything. There's very old school kind of scouting systems and traditional methods of doing this analysis. I guess linking sports analysis as well as cost estimating, where do you see those being applied and superseding what we already have?
Well, I think that one of the next revolutions in not just cost estimation, but sports analytics is really going to be how to merge expert opinion and historical data. I mean, that's something that we've been thinking about in the cost community for a while, for several years, maybe even decades. But I think in sport, there's always this tension about whether you trust the analytics or whether you trust your judgment as an expert. And let's just, for discussion purposes, put ourselves in the shoes of the manager, the coach, the skipper. And what they have to decide is whether they're going to trust what's going on the field at the very moment and what they see with their own eyes and how to interpret that, or whether they look at their tablet or their printout of the analytics and what the analytics are pointing them towards. And I guess it's fine when those things coincide and they point in the same direction, but it becomes interesting when they contradict each other. And the question then becomes, which do you trust? Do you trust your human judgment, your gut, or do you trust the data? And I think that to me is the holy grail, because you can't always rely on one versus the other. There are no absolutes that exist here. And when you have both at your disposal, knowing when to switch from one mode to the other, I think, is the key to outperforming your opponent, assuming that they only rely on one or the other, or they don't quite know when the right time is to switch.
the power in decision making is it is about having the information is one side of it, but understanding what to do with it in the moment. If we talk in terms of sports, it's microseconds, and it's just this switch sometimes that a decision needs to be made. In terms of the athlete, if you're talking team sports, then you have the manager on the side, or you have the coach, and he has to decide, which way the wind's blowing, and it can be a matter of what he sees out the corner, or he or she sees out the corner of his eye, that makes that decision, changes that decision. And it's been shown that you can have all the sports science in the world and do all the analysis and do all the preparation, and sometimes it is just on gut feel. There's things that we can't predict. I mean, you go back to 2016, and Leicester City won the Premier League, having at the start of the season been 5,000 to 1, but that was deemed as impossible. You couldn't do it because of the kind of team they were and what other teams existed. And the probabilities of that after 38 league games for them to be on top of the table it's deemed impossible. But you never know what scenarios build up, what kind of things happen in a season or in a game or in a moment that can completely change all the scenarios. But I think the power of big data, when we're talking about estimating, one problem that often occurs is the ability to generate a number quickly enough with enough quality. There's a lot of effort that goes into it. There's the planning, there's gathering of data, there's the analysis, there's scenario planning, there's all the risk analysis, the toing and froing over queries about the design and about procurement methods and other things influencing the estimate. But by having that data to hand and having the ability for machine learning to essentially automate a lot of that work, you're not taking away from the estimator and the person making the decision. It's almost like another tool, isn't it? So it kind of leads me on to my next question, and you partly discussed it there, because we were talking about the merging of expert opinion with the amount of trust you put in the data. But in this changing world, how can we utilize that quantitative and qualitative data, specifically, I think, more in estimating cost?
The principle that we have to remind ourselves about over and over is that not everything that counts can be counted, and not everything that can be counted counts. So there's a lot there to think about. And if you don't mind, I'm going to repeat that. It's an important point. Not everything that counts can be counted, but not everything that can be counted counts. And I remind myself of this over and over because these wonderful analyses tools and algorithms and methodologies and computer power, they're great, but what if you're analyzing data that actually doesn't matter? So we often have to take a step back and even ask ourselves, are we even asking the right questions here? Right? And also, what are we missing? What are our models potentially missing that actually have a huge impact on the outcome? I mean, not all the models are perfect. We know that. To butcher the infamous quote of all models are wrong, but some of them are useful. We have to remember that we might be trying to optimize something that is not as significant as we think. So that's why I think stepping back and asking ourselves how we combine historical data with expert opinion. And maybe it's not really a binary decision where it's one or the other. It's more of joining their strengths and compensating in a way for their weaknesses as well. And then coming up with a solution that is influenced a little bit by both. So really the balance is knowing when to tune that parameter, where it's almost like a dimmer on a light switch, and you're tuning it up and down or left to right, and you have enough awareness of why you're doing that. You're not just trying to experiment via trial and error. You actually have an awareness of how much you're tuning to one side or the other, and and you're learning along the way. So it's almost like a machine learning algorithm at the meta level. You're getting better over time and you're getting more experience because you're seeing almost immediate feedback. So I think that's really where I'm almost navigating from the science to the art of doing this. And I think we have to just be willing to take that leap and not live only in one dimension.
It's what you're able to model, I think, is a huge part of this. And it's not that we can take more measurements, it's that we can process more data, we can use more data, we can get access to more data now than we have before. Now that might just mean you got access to more variables. You might be able to find a relationship somewhere that might really be meaningless, but it shows that the data fits. Therefore, that must be, and I guess this is where you go into classic statistics really. But even if you go back to I think it was Forrester's model, was it, of the Earth, and trying to model by creating a systems model of the Earth, and put a lot of effort into it, and a lot of thought went into it, a lot of science, and it couldn't be done really. Maybe we can one day, but that doesn't really do what we need it to do in estimating. And I think one of the things that you've discussed is about telling story with data. There's a lot about that nowadays, about having a narrative in a visual or in a particular piece of information. It's almost becoming more important now, not just to have, like you say, a one-dimensional piece of information, but that piece of information is viewed from multiple different angles, is interpreted in different ways. So I don't know if you wanted to talk a little bit about what you think telling a story with data is, and how that applies to estimating.
Absolutely. I've given this topic about storytelling a whole lot of thought recently because I do think that all of us can get better at it. And so I think the main thing to remember is that this is all about persuasion. We want to influence a decision, or we want to sell something to somebody, whether it's an idea or a product, but essentially we're trying to persuade them. And fundamentally, there are two ways of doing this. And I'm oversimplifying the discussion, but bear with me. If you want to persuade somebody, you can either give them rhetoric, is facts, data, eh, information, PowerPoint slides, spreadsheets, and you can snowball them with that. But another way of persuading them is by telling them a story. And while most of us as engineers would probably default to the rhetoric approach, I think we can also learn a lot about the storytelling approach. And most of us, when we think of storytelling, of course, we think of books and movies, entertainment. And I'm a big fan of Pixar studios. And you are probably familiar with their movies, Toy Story, this Toy Story franchise, Cars, The Incredibles,
Mm-hmm.
Coco, all of
Yep.
these phenomenal stories that are animated, but they follow the same formula. The same storytelling formula is repeated over and over and over. And the reason why they use it is because it works. And they know that these stories trigger an emotional response from the audience and it grabs you. And the question then is, how do we borrow some juice, some special sauce from that formula? And while I think at the very broad sense, the same storytelling approach could probably be used in our modeling community, in the engineering community, I would say that it does require some important adjustments. And I can think of a few. So in traditional storytelling, your objective is to build suspense, right? Is to draw the people into your story and keep them at the edge of their seat.
Mm.
Whereas
Yep.
The storytelling that I think would be more effective for cost modeling or for engineering would be to, instead of building suspense, you actually want to give them the call to action upfront. Here's what I want you to do, or here's where I want you to, here's my recommendation. Start with that, and then you build from the ground up. Well, here's how I got there. Here's the method that I used, or the model that I used, and here's the analysis that I performed in order to get to that. And then you wrap up again with the call to action. So more of a sandwich model where you begin and end with the call to action, and in the middle is the meat of the analysis and the methodology. And I realize that's different than the storytelling that we see from Pixar, but that's fine, because what we're thinking about in a similar way is, who is our audience and what is our objective here? So our objective is not to build suspense in storytelling with models. Our objective is to persuade. So if we know that, then we're going to make some very strategic, deliberate steps to get there. Because we know that the protagonist in this story is the audience, is the people who you're trying to influence or to persuade, as opposed to the protagonist in a Pixar film might be the hero of the story, right? So a lot to consider, a lot to unpack there, but I think there are some really neat parallels between traditional storytelling and storytelling with data.
I mean, I've thought about this. It's like when you're writing something. So, like for me, when it was writing my thesis, or when you're thinking about how you're going to deliver something, it's different from a presentation, because a presentation is very similar. It's it start off with telling them what you're going to tell them. I think with storytelling, I mean, traditionally you've got the 3-act structure, exactly like you say. You build a suspense, and the hero's there, and there's something wrong, and he has to overcome something, and then something goes wrong, and then there's an enabler, or something in his life changes or her life changes, and it enables them to overcome the problem, and then everything's resolved at the end, and the audience is happy because the situation's resolved. But I think you're right. It's probably more Pulp Fiction than Pixar, in that you kind of get to see what happens in the story, and sort of at the beginning, and then it all makes sense once you've gone through the story. So then the audience kind of comes along with you, knowing what's going to happen. That is really interesting. I think the other side of it is we have got a lot more, I think, capabilities in terms of how we visualize data, and there tends to be quite a lot of complexity that goes into visualizing data and trying to tell that story without going into lots of detail. And you see this all the time, lots of graphics everywhere. But where do you see the data visualization technologies and the ability to provide such cost intelligence a lot quicker to a lot more varied an audience, and to a variety of different decision makers? Where do you see the most benefit in that?
Well, I think for estimators and storytellers, if I can call them that for a moment, I think it's important to know the difference between explanation and exploration. And when I first saw it described in this way, it really resonated with me. So the explanation part is what people want to hear. This is what your audience is there for. This is why they came to hear your talk, or this is why they asked you to write a report, because they want you, the expert, to explain. The exploration part is all the work that it required in the background in the previous weeks or months to arrive at a decision or a solution to the analysis. And I think the bias is for us to spend way too much time on the exploration, because we want to show people, first I tried this model, and then I tried that model, and then I went and collected this data, and you tell your entire life story, and you've lost your audience already. And so the advice that I give people is, let's do less exploration and more explanation. And I think it requires a little bit of mind shift, a little bit of putting your pride aside and recognizing that people will give you credit for doing the work. That's maybe not it, but you don't have to tell them everything you've done. So I think knowing and using that tool of more explanation, less exploration is a huge leap forward. Just a very basic thing that will help us make that leap. Now, in terms of some of the data visualization and data analytics, I mean, again, there are some great tools out there, and I think there's almost now too much for us to choose from, where we lose sight of what is the point here? What is the story that we want to tell? And because you don't just want to tell a good story, but you also have to have a good story to tell. And those are two very different things. Having a good story to tell means that you've actually got something useful to communicate. And the packaging is important, but fundamentally, do you have a good story to package to begin with, right? So just something to
Yeah,
consider.
you can dress it up, however, but if you haven't got a story to tell, then there's no point in it, and people will quickly catch on. I guess was it style over substance? I guess sometimes, but I don't know. So I think there's so many areas I could take this, but I think what I wanted to do, because we've only got a few more minutes, is bring it right back around to sport. And there's something we haven't mentioned yet, which is the science and sport program that you developed at Arizona. I think it's really worth the audience really knowing about this program that you've championed, and I think it's something that we could do with over here. So I don't know if you spent a few more minutes just talking about science and sport.
I would love to, because that's been a passion of mine for a few years now, and it's really motivated by upstream thinking. And if you consider the impact that a university faculty member can have, it's fairly limited if you only focus on the students who arrive at the university. But if you really want to impact people choosing, young students choosing a STEM career, you have to go back upstream and try to influence them at a younger age. Because most students decide at a young age whether or not they like mathematics and whether or not they like science. So it's almost like turning back the clock and going back and thinking about your younger self, and at what point did we decide that we liked or did not like certain subjects. And that's really what motivates the science of sport, which is looking to inspire those kids. And I'm talking 8, 9, 10-year-old kids to look at math and science through the lens of sport. And you mentioned cricket and football. Those drive passion for people, and they are religion, right? And we have the same thing in the US. I mean, the most popular sports here are American football, baseball, basketball. So if you can get students at a very young age to think about abstract concepts in the context of sport, I think you have a much better chance of success, of getting them interested, getting them engaged, and most importantly, helping them see real life connections, real world connections to these things that they would probably dismiss, because they would assume, I'm never going to need that. Why would I ever need to know the Pythagorean theorem? That's really not going to get me through life, is it? Well, it turns out you can draw triangles everywhere in sport and illustrate how the Pythagorean theorem will help you figure out how to be a better passer in football, or how to throw better in baseball, or how to meet your receiver in American football. So you can imagine all of these great connections that can occur with Newton's laws of motion, or analytics and statistics, or physiology and biology. So what we've essentially done as a official charity here in the U.S. is developed programs for professional sports teams of various sports to take the curriculum that these students already have to learn at that age group, 8, 9, 10-year-old age band, and put it in the context of the sport, but also the local team. And that is a win-win for schools. It's a win-win for the sports teams because they do something good for the community that also disseminates their brand. And it's a win-win for the universities as well because we're essentially building a larger pool of students who might be interested in going into these fields, these STEM fields that are, I think, more interesting, more impactful from a global competitiveness standpoint. So that's I've immersed myself in that, and it's been great fun. And as you can probably hear, I'm passionate about it. But most importantly, it was an easy switch from cost modeling to sports analytics.
Definitely. I mean, that that acting as an enabler for it. The passion definitely does come through in the way you're talking about it, and you're absolutely right. It's such a win-win. I was pretty mad about football when I was growing up, but it always seemed more about the athleticism than anything about the scientific reasoning in them. I'm assuming that it does exist in pockets, but not really as something that I've seen. But I can see it encouraging a lot of people to go into sort of STEM subjects, and at the very least, even if that stokes a fire in them, then the pool of knowledge that you have at that point versus. I think there's quite a struggle in terms of engineering numbers and scientists who coming out of universities. If you can encourage that as well as improve England's chances of winning the World Cup, I guess is the way I would say it. But no, I think it's absolutely fascinating. And I was just wondering just where we can find out a bit more about science of sport and anything else you might be working on now.
Absolutely. We have a website, sciencesport.org. And if you want to have a look there, we have a series of resources for educators. We have videos, and we're also working on an app to gamify the curriculum and be able to also disseminate it to a broader audience. So check out sciencesport.org. In terms of what I'm working on next, and this is a bit of a preview, but I'm working on a book on decision making. And as you can imagine from everything we've talked about, that is one of the important themes in making estimates credible, but also just even knowing where to look and how to quantify these important factors. So I'm working on a book in that area of decision making, but really the sub area of situations that actually are counterintuitive. And I'll give you just a brief example. Most people in the software development community are aware of Brooks' Law. And Brooks' Law was developed by Fred Brooks, who was an engineer in the early days of IBM and later went on to a faculty position at the University of North Carolina. And what Brooks' Law says is that adding people to a project that's already late will actually make that project even later. And that is a counterintuitive example of something that a manager might not initially think about, that by adding more resources to a project that's late, you're actually making it worse. And that is one of the many examples that I write about in the book. And I hope I'll be done with it next year, and you'll see it at a local airport or Amazon bookstore near you.
And that's the end of this week's episode. I really enjoyed this one. There are aspects of the art of estimating that we should consider in addition to the number. I like the idea of estimators as storytellers, and our ability to visualize and share information in different forms should really be explored in the field of cost. I also love the synergies with sports analytics, and would be really interested on what your thoughts were on how you think estimating could be applied to sport in other ways. The links for Science of Sport and a bit more about Ricardo, plus more, are in the podcast description. Thanks for listening, and until the next episode, stay safe and have a great week.